Okay, welcome back, kiddos. Now we are talking about moving on to 7.5 and properties of trapezoids and kites. So these are other types of polygons. Specifically, today we're going to be talking about quadrilaterals, right? And we know quadrilaterals, the quad part means four sides, right? So these are two specific quadrilaterals, trapezoids, and kites. So what I'm going to do today is a little bit different as far as the notes. I'm not going to use a highlighter because I know some students aren't using that. But if you prefer to use a highlighter, that's cool. Otherwise, we'll just use our normal pen. Okay, so I'm going to change. So first off, let's talk about non-isosceles trapezoids. Okay, so you may remember what isosceles means. Okay, from before, but non would be the opposite of that. So let's think about that. Non-isosceles. Okay, isosceles means two sides are the same, right? So non-isosceles means all sides are different lengths. Okay, all sides are different lengths in a non-isosceles trapezoid. Okay, so we said it is a quadrilateral, right? Because the quadrilateral means four sides. But specifically on a trapezoid, then, a trapezoid means it has exactly one pair of parallel sides. Okay, so if we look right over here, okay, this, remember, means parallel. Okay, so these two are the parallel, one pair of the parallel sides. So let's name those. What would we name this side? Okay, remember we do it with the two letters, so this would be named EF. Okay, so we would say EF. Okay, and we would of course have that symbol on top that means a line segment. EF and HG, right, or GH. Okay, so those are our parallel sides. Okay, then also in a non-isosceles trapezoids, because it only has one pair of parallel sides, then it of course has one pair that are non-parallel. Right? So which two sides are non-parallel? Okay, that's right. It would be EH and FG. Okay, so EH line segment and FG line segment, right? And so what we need to just remember is the parallel sides. Oh, I wasn't going to highlight that, but okay, parallel sides are like this and that. Okay, so I think actually for many of y'all the highlighting is better. So let me just do that, and so you can just decide if you want to highlight to see how it pops out like that. So that's why I do that, so we can see that color-coded parallel means that. Okay, so non-parallels are going to be those. And then two pairs of consecutive interior angles. Okay, so those are key words. All right, consecutive means in order, next in order, right? Next in order. Right? Like 1, 2, 3, 4, 5 consecutive, right? We know interior means inside. Okay, and the angles, right, are in the corners. All right, so let's talk about that then. It says two pairs of consecutive interior angles. Okay, so has two pairs of consecutive interiors. So this would be like this angle right here, okay, and this angle right here, right? So we can think of it like these two pairs of consecutives would be like going here and here. That would be one. So this first one, we would call that GHE, right? Angle GHE. Angle GHE. Okay? And then I'm just going to change it to a different color so you can kind of make it pop a little bit. So we said the consecutive would be in order, right? So this one is the first one, then the next one would be this one. So I'm going to put that in a different color. Okay? So we can say HEF. Okay? That angle HEF. So angle HEF. Okay, and so it has two pairs, right? So the other two pairs would be right over here, right? EFG. So angle EFG, and the other angle, the next consecutive, right, would be this one right here, right? So FGH, angle FGH. Okay, so it has two pairs of what we call those consecutive angles. So that will come in later lessons, especially. All right, so let's talk about that over here. One thing, okay, let's look at this first example right over here. Okay, so with that, we have some relationships that always come up. All right, so let's look at this example. It says, what is angle K? Okay, what we want to remember with the consecutive interior angles is they are supplementary. Okay, what does supplementary mean? Supplementary means adds to 180 degrees. Okay, so consecutive interiors add to 180. So if we're looking for angle K, measurement of angle K, that's this right here, right? We could have called it JKL. Okay, so remember, we can call it by those three or by the vertex, right? That's the middle of the vertex. So this is measurement of angle K. So we're asking, what is that? Well, if they're supplementary, and we know this one, K and L, right, are supplementary, that means these two have to add to 180, right? Okay, so if those add to 180, to find out K, we would just do 180 minus 51, right? So we just type that into our calculator, and that would give us 129 degrees, right? So that would be K is 129 degrees, okay, because these are supplementary. All right, now thinking about that, this next question is asking for M. Okay, so think about that for a moment. If you got that, go ahead and try it. Pause it and try it. Well, what do we know about M? We don't know. It looks like it's 90, right? But we don't know for sure because we don't see that box there. So we're not going to assume it's 90, okay? Because we know we can find the properties that both of these have to add to 180, right? So if they add to 180, we can say 180 minus 87, okay? And if we put that in a calculator, it gives us 93 degrees. Okay, so angle M is 93 degrees because these are supplementary, right? Because these add to 180. That's how we know how we got those answers. Okay, so maybe I'll highlight over there too. It tells me all that. Okay, good. So now, keeping that in mind, see if you can get number 2 on your own. Okay, pause the video for a moment. See if you can get number 2. All right, well, let's look at it. So it says angle C. What do we know about angle C? Okay, we don't know anything about it other than C and B add to 180, right? So I would just say 180 minus 31. Okay, if I put that on a calculator, that gives us 149 degrees, right? So that one has to be angle C. Right? Now, what about D? If you didn't get that one, see if you can get D. Okay, angle D, this and this have to add to 180. So we would say 180 minus 62, right? That would give us how much? That would give us 118 degrees all day, right? That has to be this angle D. Okay, so let's go ahead and highlight that real quick to make that pop. All right, so we got the 118 because these add to 180, right? And we got these add to 180 right over here, and that's how we got to that. Okay, so those are our two answers. Maybe a box set, maybe a box set. All right, let's keep it moving. Let's think about number 3. Ooh, okay, number 3. Now we're stepping it up, okay? So, but that's no big deal. We talked about it, and now we're just going to apply our math skills we've been practicing all year. So it's the same thing, just with different numbers, right? With this, we have variables. We can work with that. We know that these have to add up to 180. These have to add up to 180. So we know these have to add up to 180. So if they're asking for angle O, one thing we know is we don't know what this whole value is until we have x, right? So that's what we're thinking. How can we find out x? Okay, well, just like we've been always practicing before, we need to come up with a equation that makes sense with that, right? So we need to have an equal sign, right? And we know that equals 180, right? Well, what equals 180? Well, if we add both of those, that adds to 180, right? So we would say 12x plus 3, right, plus 7x minus 13 equals that 180. Right? So that's a true statement, right? If we start with a true statement, then if we solve for the x, then we can substitute and get our answer, right? So pause the videos and see how much you can do, and then unpause, pause, step by step, okay? So see if you can get the next step. All right, so hopefully we thought about, we're going to combine the 12x and the positive 7x, right? So if we put that in our calculator, that gives us, let me put that a different color. That's going to combine into 19x, right? Okay, so now let's think about the constants. Okay, so we have a positive 3 here and a negative 13. If we combine those by adding those into our calculator, right, 3 plus negative 13 gives us negative 10, right, equals 180. Okay, now it looks maybe a little bit easier, right? Now we're going to work with the x last, right? So think about what we do next. Yeah, that's right. We're going to add the opposite of that negative 10, right? So opposite of negative 10 is going to be positive 10. I like to draw a line down there in the middle. I think that helps separate it and get it organized, especially when we're first learning it. Okay, so if I add 10 over here, if it's equal and balanced, I have to do the same thing. Otherwise, it would not still be equal, right? So you got to do that. Now let's work from left to right, just like we were reading the book. The 19x needs to come down. Okay, and then we have these two opposites right over here, right? We know the two opposites just cancel out. And then on the right side, 180 plus the 10, we don't need our calculator. We know that's 190, right? Okay, so now we're just going to divide both sides by 19. Okay, so I think you can do this in your head. Think about it for a moment. Okay, well, what do we know? 190 divided by 19 means what number times 19 equals that, right? You can put it in your calculator if you're not sure, but of course it is 10. All right, but that's not quite our answer. We're thinking about what is 7x minus 13, right? So if we do that, then we're just going to plug in, instead of the x, we're going to put in 10, right? So we're going to say 7, and we're substitute and put a 10 right there, right? Minus 13. Okay, so that's going to be equal to 7 times 10. We know is 70 minus 13. All right, so you can put that in your calculator, or you could have just put that whole thing in your calculator. Either way, we're going to get the same answer, right? That's what I love about math, is that no matter what, we're always get the same answer. That's going to be 57 degrees. Okay, so that's what we want to know about non-isosceles trapezoids. Okay, so keeping that in mind, let's talk about isosceles trapezoids. Okay, so we said non-isosceles trapezoids have one pair of parallel sides, but all the sides are different length, right? That's the main thing. All the sides are different length. On this, sorry, I'm trying to maneuver this. On the isosceles, we know that isosceles means two sides are equal. And not only the two sides, but two opposite sides. Okay, so they have to be opposite each other. So if we look right over here, these two marks indicate that these two lengths are the same side, right? And same length means congruent, right? Congruent means same lengths, right? So we have two legs that are the same length. And remember, legs are the sides, right? So let's name those. What are the two legs that are the same length? That would be AB and CD, right? So we would say AB, line segment AB and CD. Okay, those are going to, and maybe we put those in red too. Okay, so that's going to be the congruent legs. All right, now diagonals are congruent. So diagonal is if we go from opposite corners. Okay, so opposite corners. So opposite means like if we shot an arrow, right? So this is a diagonal and this is a diagonal. Okay, so maybe we put those in a different color. Okay, what would we call those, right? So if those are diagonals, we would say that one's AC, right? And BD, right? So AC and BD. Okay, so those are the diagonals. All right, and then the last thing, okay, so it has, the isosceles has all the same properties of non-isosceles. Okay, so it has the consecutive angles that add up to 180, and it has the parallel sides, just like we talked about. Okay, but also each pair of base angles are congruent. So the base angles, base are meaning the bottom, right? Bottom, right? So the base angle would be this one, right, and this one. So we can call it angle A and angle D, but or we can call it angle BAD, right, and angle ADC, right? BAD, ADC, right? Angle BAD and angle ADC. angle ADC. All right, so let's keep that in mind. Let's look at this one right over here. Okay, so this says measurement of angle K and the measurement of angle L. So think about this for a moment, see if you can get this. All right, so what do we know? We're trying to find L. Well, what do we know about L? If this, right, let's look at our hints, right? We see this hint right over here. This tells us that this side and this side are congruent, right? If those two are congruent and that's parallel, then it's a isosceles trapezoid, right? So the base angles are congruent. Remember, we said congruent means equal, right? So that means this one and this one are equal, right? So then if that one's 23, then we know L has to also be 23 degrees. Okay? All right, so that's using that information. Now, let's see if you can get K on your own. Pause the video. Okay, well, what do we know? We don't know anything about those, right? But if these two are equal, right? So if we go across there and we go across there and these are parallel, then these two are going to be equal. Well, what do we know then? If this is 23 and that one's 23, that means what's left has to be for that, and then we just divide by 2, right? So let's do that. So we're going to say 23 plus 23, right? That's going to be equal to 46, right? So we're going to say 180 minus 46. That's going to be equal to 134, right? And then we're going to divide that by 2. So if we put that into our calculator, 134 divided by 2 gives us, that's right, 67 degrees. 67 degrees. Okay, so that's what we want to keep in mind with these. So I know these are new terms, but we got this. Okay, non-isosceles means all sides are different lengths. On a trapezoid, though, that means one pair are parallel, right? So these two are parallel, these two sides are not. All sides are different. Okay, these two angles add up to 180. These two angles add up to 180. Okay, that's what we want to know. All right, so then on this, it's all the same thing as this, except for these two are equal, right? We see these two aren't. These two are equal, so what that means is this angle is also equal to that one, but these still add up to 180, and those still add up to 180. And then this angle and this angle are also equal to each other. Okay, so keep that in mind, and now let's move on. All right, now we're going to talk about let's go and talk about these properties of the mid segment. Okay, so let's think about what a mid segment means. Mid means middle, right? So the mid segment is parallel to each base. Okay, so if we see over here, this is a base and this is a base, right? We have two bases, right? So it's the sides that are parallel with each other, right? So the bottom, we know base is bottom. The top, right, is parallel with it, so those are both the bases. Okay, the mid segment is parallel to it. So if we see this and this is the mid segment. That's the middle. Okay, and the thing is, it's 1/2 of the sum of the lengths of the bases. Okay, so 1/2 the sum of the lengths of the bases. So let's talk about this. The mid segment of this one is going to be called what? The mid segment is this right here, so it's going to be called MN. Right? So we'd say that's going to be line segment MN. Okay, so which segments are parallel? Okay, hopefully you said AB, MN, and DC. All three of those, right? So AB, line segment AB, line segment MN, right? And line segment DC, right? Those three are parallel. And how do we know that they're parallel? Because we see those symbols, right? So parallel has those symbols. How about we put that in a different color? Parallel, that one, right? That one, and that one. Those are all parallel. And this one, you can still see is blue because that's our mid segment. Okay, so here's the formula. We said the mid segment is 1/2 the sum of the lengths of the bases. Okay, so the sum of the lengths of the bases, how would we write that? The sum of the lengths of the bases. Let's just do it like this. Okay, so base number 1 plus base number 2, right? That's the sum of the bases. And 1/2, of course, means divide by 2. Okay, so that's our formula. We're just going to add the bases and divide by 2. Another way of thinking of it is 1/2, right, times base number 1 plus base number 2. Okay, so either way, of course, is the same thing, right? Multiplying times 1/2 is the same thing as dividing by 2. So I like thinking of it like this. We're just going to add them up, divide by 2. Okay, so let's think about that on these two problems. These problems right over here. Okay, so let's take a quick gander. Okay, CD. Let's think about this. Think about this for a moment. See if you can get this one on your own. All right, CD. It's this right here. Okay, if we notice, of course, it's off to the side, but we know this one is parallel with this and this. It's 4 sides, so it's a trapezoid, right? So we know that we can use the mid-segment theorem to figure this out, right? So we said base 1 plus base number 2 divided by 2, right? So let's do that. We're going to say base number 1 is 12 and base number 2 is 36. So 12 plus 36, right, divided by 2. Okay, so if we put that into our calculator just like that, we would come up with an answer right over here. But let's do it without that first. See if we can do it in our head, right? 12 plus 36, we're going to get 48, right, divided by 2. Half of 48 is 24. Okay, so we can do it either way with our head or with the calculator. Alright, so now this is a different variation. Let's look at 7. This is a higher level. So think about this for a moment if you want to push yourself. See if you can get it. Alright, let's talk about this. Alright, so let's look. Now what do they give us? They want CD, which is this right here. Okay, so they're not specifically talking about the mid-segment, but we are using the mid-segment. Well, what do we know about that? Well, we know that mid-segment is equal to base 1 plus base 2 over 2, right? So that's what we want to key in on. That's what we're thinking about. Ooh, so CD was 24. Okay, so if we think base 1 plus base 2 divided by 2, right? That's another way we can look at it. Let's think about that. That's equal to the mid-segment. If the mid-segment's equal to that, let's talk about that. That's the mid-segment, right? Mid-segment's equal to that. Let's fill in the gaps. All right, so let's start with our equal sign. Let's do our this. All right, let's talk about that. What's the first base? Okay, well, the first base would be this, right? We don't know what that is, so what would we do? We'd say that is x, right? So we put x there, right? Plus the second base. What's the second base? Second base is 0.6. Okay, so we'd say 0.6 there, right? Then we said divide by 2 equals, and then here's the mid-segment, right? What's the mid-segment? Mid-segment is 1.8, right? So those are the two numbers that we're going to use, 1.8. Okay, but now that looks really gross, right? I know that looks gross, but what do we talk about? Anytime we see a fraction over here, remember I said my easy way to look at it is just put it over 1 and cross multiply, right? We can say this times this, right, is going to be equal to this times that, right? So I like doing my variables first. Let's look at that. 1 times x plus 0.6, that's weird, right? But 1 times anything is still the same thing. So 1 times x plus 1.6 is still going to be x plus x plus 0.6, right? Equals, then we said 1.8 times 2. If we put that in a calculator, we get 3.6. Okay, now that looks much easier, right? Even though it's a decimal, we know we're just going to do the same thing. Go and finish this up if you can. All right, hopefully you tried. We're going to subtract the 0.6, right? Subtract 0.6, you know that. All right, so that means x equals 3.6 minus 0.6 gives us 3. So x equals 3. So CD is 3. All right, so that's enough for today. We'll talk about the other stuff at a different day. So let's go and do those practices and let me know if you have any questions.